Okay, question 4 has given us a ramp A to B. They've given us a length. As soon as they start talking about lengths, you need to think that moments are involved in this question. The ramp has mass 20 kilograms. It rests in equilibrium on a rough horizontal surface. That's going to be important. That means there's friction acting between the ramp and the surface. The ramp rests on a smooth, solid cylindrical drum, partly wedged under the ground. The drum is fixed. This length is 5. We've got an angle tan theta is equal to 7/24. So we can do for that, as soon as I see that, I'm going to draw the triangle again like we did on question 3 and say that's going to be 7 and that's going to be 24. And we can work out the hypotenuse, and that'll give us sine theta and cos theta. 7 squared plus 24 squared is 625. So that means this length here is 25. So sine theta is 7/25 and cos theta is 24/25. Okay, let's carry on reading. It says the ramp is modelled as a uniform rod. Okay, so the fact that it's uniform means that its weight will be coming from the centre of the ramp, which means this length here is 4 and this length is 1. Let's keep reading. Then part A says, explain why the reaction from, so this is useful, it's telling you to remember to put your reaction forces in. Explain why the reaction from the drum acts in a direction perpendicular to the ramp. So that's a tricky question to answer. We might not necessarily know the answer to that question, but that's a really useful piece of information. Even if we can't answer this question, that's going to allow us to add in the reaction at C and know that it's perpendicular. The reason that it's perpendicular is because earlier on they told us that the drum was smooth. So there's no forces acting horizontally here, which means the only force acting is the reaction force, which will be vertical or perpendicular. So it's because the drum is smooth, so no friction between the drum and the ramp, so the reaction will act at right angles to the ramp. But as I said, don't worry if you can't answer that question, because that's now going to unlock part B, which is a 9-mark question. So if we go back to our diagram from part A and take everything that we've written down from part A, I'm going to now have the fact that the reaction at C is perpendicular, and we can carry on reading. Then it says find the magnitude of the resultant force acting on the ramp at A. So it's asking for this force here. Now remember, they said that the reaction, the ground was rough. So that means that there will be friction. There will either be friction acting this way or this way, and you've got to work out, you've got to think about this just in real life, common sense, which way will the action be acting. If that beam was to move, if that ramp was to move, it would slip down this way, which means friction is fighting against this motion to the left, and that tells us that the friction is acting towards the drum. So we can add that in. That's your friction. The reaction at A is going to be perpendicular to the surface, so I'm going to call that RA, and that's what we're being asked to find. We're being asked to find the magnitude of that force. So we've got loads of information on there. It would make sense to resolve everything parallel and perpendicular to the Do we want to resolve parallel and perpendicular, or do we want to resolve vertically and horizontally? I'm going to resolve vertically and horizontally, and the reason I'm going to do that is because there are more vertical and horizontal forces than parallel and perpendicular. We've only got this force here, which is not vertical or horizontal. The other three are. So I'm going to resolve this RC force. And then when we look at the forces, we're going to look horizontally and vertically. Now, what will this force be? It will be an angle of, this angle here is going to be theta. That, let me just draw that in quickly and then delete it. This angle here is 90, which means this angle here is 90 minus theta, and therefore the orange angle, you can see the orange lines also make a right angle, which means this angle in here is also theta. This angle here is theta, which means that this is RC cos theta, and this is RC sine theta. Okay, so we can do forces up equal forces down. It is in equilibrium, right? Let's just check that. Yeah, rest in equilibrium. Forces up equal forces down. Forces left equal forces right. And clockwise moments equal anti-clockwise moments as well. So we can do three things there. Let's look at the forces first. Let's look at the upward forces. We've got that RC cos theta plus RA needs to equal 20 newtons. RC cos theta is 24 over 25. So 24 RC over 25 plus RA needs to equal 20 newtons. If we look at forces left and right, the friction is going to equal RC sine theta. They're the only left and right forces. FR equals RC sine theta. Sine theta is 25. And then if we look at moments, now we've got to think about where we want to take moments. If we take moments about, we're trying to find A. So let's RA. Let's take moments about A, and that will allow us to find RC. because that's going to take out the friction and RA. So for the moments about A, we're going to have because the pink ones are going to go and the orange ones are the resolved forces of RC. We've just got RC and the 20 G newtons to look at. 20 G newtons is a slightly harder one. We've got to look at this triangle here. It's going to be 20 G newtons times the perpendicular distance to A. That's going to be this length here. If I redraw that triangle, we've got 4 meters, theta, and this length that we're looking for. That's going to be, X is going to be 4 cos, because it's the adjacent theta. So that's 4 times 24 over 25. That's 96 over 25. So we're going to have 96 over 25 times 20G. Equaling the moment that's anti-clockwise. That's going to be RC times the perpendicular distance. This time the perpendicular distance is there already. It's the 5 meters. So we're going to have 5 RC. If we divide by 5, we're going to get RC. That's coming out at 150.528. Okay, so that's RC. We can now go backwards and find the friction. It's going to be 7/25 of that. That's 42.1784. And then we can go back and get RA finally as well. RA is going to be 20G minus 24 RC over 25. That's 51.49. Okay, so we've got all the 3 forces now. So now we can go back and actually answer the question. The question wants to know the magnitude of the resultant force acting on the ramp at A. So the resultant force of the 2 forces acting at A. So we know they're the 2 pink ones. So we're looking to find a force that's going to be acting in this direction that's the resultant of FR and RA. So we've got FR acting this way. We've got RA acting this way. So the resultant of that, let's call that big R, is going to be, well, we just do Pythagoras. We've got 51.49312. FR was 42.1784. So I'm doing the real numbers squared here. I'm just rounding them for ease. I've got 66.56. Okay, part C, just a quick 1 marker again. It says the ramp is still in equilibrium. Let's look at the picture again. The ramp is still in equilibrium, but the centre of mass is now closer to A. So this 20 G newtons is closer in here. That length is not 4 anymore, it's less than 4. how would the magnitude of the reaction between the ramp and the drum at C be different? So what would happen? Well, if we look at the maths that we've done in part B, where did we use that 20G? Where did we use the length of 4? And we used it when we were working out the moment. So this moment would be less. If that moment is less, but it's still in equilibrium, that means the anti-clockwise moment will be less. But the only thing that we can change about the anti-clockwise moment, because that length is fixed, is the reaction at C. So if this side is smaller, then this side needs to be smaller too, which means RC will be less. The reaction at C will be less than it was before. So the moment the clockwise moment from the weight will reduce if the centre of mass is closer to A. Therefore, the reaction at C will also reduce because they're equal. Because it's in equilibrium. Okay, so that's what we're looking for. The reaction will be less.